back. So let me recall. First derivative test for absolute extreme values. You suppose C is a critical number of a continuous function f, and if f prime greater than 0 to the left of C, that is when x is less than C, that is left of C, and f prime less than 0 to the right of C, that is x greater than C, this is the picture. Okay, so that will fetch you a maximum here, an absolute maximum. If you, this is the boundary, okay, you have a bounded interval. Likewise, C, if a critical number for all x to the left of C, f prime is less than 0, and all x to the right of C, f prime is greater than 0, then you have an absolute minimum. Okay, absolute maximum, absolute minimum. Remember, this must happen for all x to the left of C. This must happen for all x to the right of C. Likewise here. And second derivative test tells you at C, if second derivative is less than 0, then you have some kind of maximum. Okay, that could be a local maximum though. Likewise, if second derivative is greater than 0, you will have a local minimum. You are not guaranteed an absolute. First derivative test is a better test because it gives you absolute values. As long as this happens for all x on the left, all x to the right, and so on and so forth. Let's use our tests for business and economics. So some terminology. We call Cx the cost function. It is the cost of producing X units of a certain product. Okay, Cx is the cost of producing X things. Say you're producing chairs or mugs or whatever. X number of those things is a cost. Cx is the cost. Marginal cost, marginal anything means the rate of change. Okay, in other words, marginal cost is the derivative C prime of X. All right, let's consider marketing. Let Px be the price per unit that the company can charge. Px is the price per unit. Then P is also called the demand function. It's also called price function. Demand function. We should expect it to be a decreasing function of X. Why? Well, price per unit. Say I am selling 10 books. Well, if I want to make $200, each book I'll sell for $20. But if I'm able to sell 50 books, you see, then if I want $200 to make for it, then I should be charging $4. You understand? So if I sell more items, I'm expecting price per unit to be decreasing. Okay, so we expect it. All right, so cost function denoted typically by Cx, cost of producing X units. Marginal cost is C prime X. Px is the price per unit. It's also called demand function, the price function. Next, Rx, that is the revenue. Now, quantity times price, that is the revenue. Quantity means the number of units sold. All right. Typically, you are selling X number at certain price per unit. So multiply X to that price per unit. That is your revenue function. Okay, the derivative, okay, is called marginal revenue. It is the rate of change of revenue with respect to the number of units sold. If X units are sold, then the total profit. What is profit? How much money you get minus how much you spent. Revenue minus cost. that is your profit. Marginal profit is derivative. All right. Always marginal something is the derivative. It is the rate of that particular quantity. So here is a concrete example. A store has been selling 200 flat screen TVs a week. So every week it has been selling 200 flat screen TVs. They are charging $350 each. A market survey indicates that for each $10 rebate offered to buyers, the number of TVs sold will increase by 20. So when there is a $10 rebate advertisement anywhere, well, they are expecting 20 more people to purchase a week, right? Find the demand function and the revenue function. How large a rebate? So they want to see how much the rebate should be to offer, should the store offer to maximize its revenue. They want you to maximize the revenue. So solution. Start with X, number of TVs sold per week. Then the weekly increase in sales is X minus 200. See, you're already selling 200. However much more you sell is X minus 200. For each increase of $20, price is decreased by 10. That's what the rebate effect is. You decrease price by 10, you sell 20 more. Okay, this is a bit tricky to understand. What that means is, for 20 units to sell, you decrease the price by 10. So for 1 unit sold, you will be 1/20th of 10 decrease in price. So the demand function is 350, which is the original price of the TV, minus 10/20th of the additional number of TV beyond 200. You see, X minus 200 is the additional you sell. 10 by 20th of that is the reduction in your price per unit. Simplifying, so this 10 over 20 is nothing but half. So minus half X is this guy, and half of 200 is 100, added to it 450. Do you understand why add? Minus and a minus is a plus. Anyhow, when you simplify this, you should get this. Okay, this is price per unit. What is the revenue function? Revenue is number of units sold, which is X, times price per function. Now price per unit, PX. X, PX. X 450 minus X times this one. So half X squared. So you want to maximize revenue. Whatever you wish to maximize, take its derivative. Okay, and set it to 0. You get X equals 450. This X gives an absolute maximum by the first derivative test. Or notice, what is R? R is a parabola and it opens down. So the critical number will give you the maximum. Alright. Put that critical number 450 in your price per unit function and you get 225. So price per unit is 225. So how much is the rebate? From 350, you take away what your price per unit is. The difference is your rebate. Okay. Thus, to maximize revenue, the store should offer a rebate of 125. Okay. It is a bit intuitive. You have to work hard at these problems. Okay. Next videos on, I will work on a few examples on section 3.7 from our web work. Okay. Until then, bye.